Hi everyone, I'm Saishri, studying in Sri Venkateshwara College of Engineering, first year Ferrari section. Today we're gonna discuss about curvature and the radius of curvature. The topics covered in this are introduction to curvature and the radius of curvature in mathematics, curvature of a curve and calculation of curvature and the radius of curvature, relationship between radius of curvature and the curvature. The first topic is Introduction to Curvature and the Radius of Curvature in Mathematics. Curvature is a fundamental concept in the mathematics that measures the amount by which a curve deviates from being a straight line. The radius of curvature, on the other hand, is the radius of a circle that best approximates a curve at a particular point. These concepts are used in various branches of mathematics, including mathematical geometry, calculus, and differential equations. First, we are going to discuss about the curvature of a curve. The curvature of a curve at a point is defined as the reciprocal of the radius of curvature oscillating circle at that point. It provides information about the rate at which the curve bends or changes direction at that particular point. Curvature is typically denoted by the symbol small k. By the small letter, not the capital one, it is denoted by the small letter k and is measured in the units of the inverse length such as radians per meter. Calculating curvature. The curvature of a curve can be calculated using the formula small k is equals to mod dt by ds, where the t is the unit vector tangent and s is the tangent parameter. Another common formula for curvature is k is equals to mod d theta by ds, where theta is the angle between the tangent vector and the x-axis. While practicing, those formulas are derived using differential calculus techniques. Next, radius of curvature. The radius of curvature at a point on a curve is the radius of the circle that best approximates the curve at that point. It represents the curve of the curve at that particular point. The radius of curvature is denoted by the symbol capital R and is measured in the units of length such as meters or centimeters. Next, calculating the radius of curvature. How can we calculate the radius of curvature? Here is the formula, and the radius of curvature can be calculated by using the formula r is equals to 1 by k, where k is the curvature of the curve at a given point. Alternatively, the radius of curvature can be approximately using numerical methods or geometrical construction. In some cases, the radius of curvature may vary along the curve, indicating changes in the curvature of the curve. Next, we shall discuss about relationship between the curvature and the radius of curvature. The curvature and the radius of curvature, they are inversely proportional to each other. Higher the curvature value indicates sharper bends in the curve, resulting in smaller radius of curvature. Conversely, lower curvature values corresponds to gentler curves with tangent target radius of curvature. Applications of curvature and the radius of curvature. Curvature and radius of curvature have numerous applications in various fields of mathematics, physics, and engineering. These are used in computer graphics to create smooth and realistic curves in digital animations and simulations. In civil engineering, curvature and radius of curvature are essential for designing roads, railways, and pipelines to ensure safe and efficient transportation. Curvature in differential geometry. In differential geometry, the curvature of a surface is measure of how the surface bends and derivates from being flat. Gaussian surface and the mean of the curvature are two important measures of the curvature of the surfaces. These concepts play a crucial role in understanding the geometry of surfaces and their properties. Mathematical tools for curvature analysis. Calculus plays a vital role in analyzing the curvature and radius of curvature. Concepts such as differentiation, integration, and the limits are used to derive formulas and to solve problems related to curvature. Additionally, differential equations and numerical methods are employed for approximating curvature and radius of curvature in complex curves. Let's conclude to the topic. Curvature and radius of curvature are fundamental concepts in the mathematics that provide insights into behavior of curves and surfaces. They are calculated using formulas derived from differential calculus techniques. These concepts have wide-ranging applications across various disciplines and are invaluable tools for understanding the describing and the geometry of curves and surfaces. The formula to find the radius of curvature is equals to rho is equals to 1 plus y1 square 3 by 2 divided by y2. Let's solve the problem by using the formula where rho is equals to 1 plus y1 square 3 by 2 by y2. Y is equals to a log secant x by a. First, we should differentiate with respect to x. Here, the differentiation of log secant x by a is 1 by secant x by a into secant x by a into tan x by a, and the differentiation of a is 1 by a. Then we should differentiate the given value again. Then we'll get y1 is equals to tan x by a. Differentiate with respect to x. y2 is equals to tan x by a. It can be the differentiation of tan x by a is secant square x by a into 1 by a. By using the formula rho is equals to 1 plus y1 square 3 by 2 by y2, here we can substitute the values of y1 and y2 which we got. Here the y1 value is tan x by a. 1 plus tan square x by a whole 3 by 2 by secant x by a. 1 plus tan square x by a can be written as secant square a. Here rho is equals to a secant square x by a 3 by 2 by secant x by a. Here 2 and the 2 get cancelled. We'll get secant a secant cube x by a by secant square x by a. Secant square x by a, secant cube x by a get cancelled. The final value we'll get is rho is equals to a secant x by a. Here is the solution for the problem y is equals to a log secant x by a. Thank you.